Hello class, welcome to Pre-Algebra Lesson 2.5, which is all about solving equations using square roots and cube roots. By the end of this lesson, you should be able to solve equations involving squares or cubes. Before I jump into that first example, I just want to look at a couple of things that we've learned about, but I haven't explicitly said before this point. So I'm going to start by talking about some squares, okay? So if I asked you what is 3 squared, hopefully at this point you remember that means 3 times 3 instead of 3 times 2. That 2 just tells us how many 3's we are multiplying together. And if you were to do that 3 squared, you'd say 9. Okay, now I'm going to mix things up a little bit. What if I said negative 3 squared? Some of you are instantly going to answer and say negative 9, but let's think about this for a second. That 2 tells me I have 2 negative 3's that I'm multiplying together, right? So negative times negative is positive, and 3 times 3 is 9. So notice that even if I take the negative version of a number and I square it, it becomes positive, okay? And now I'm going to go kind of one step further. So we've started talking about square roots, right? So if I ask you what's the square root of 9, up to this point, you've just been saying 3. But that's not entirely true yet, because there's that negative 3 that it could also be, right? So it could be a 3 or a negative 3. So I'm going to introduce, wrong number. I'm going to introduce a new mathematical symbol, because I know you guys don't like writing things out. So instead of saying 3 or negative 3, a faster way to write this is you can do a plus minus, which means positive or negative 3. Okay, and you're going to see me use this notation today. That's why I wanted to make sure to introduce it to you. There will be some instances where when you're doing the square root of a number, where the negative version just isn't going to make sense. Some examples include if you're ever talking about distance or length, we can never have a negative distance and we can never have a negative length. Sometimes students view that as, well, if it's negative, it just means you're moving backwards, and that's not going to be the case. Even if you're moving backwards, you are still covering distance, right? Like if you were to run the mile in gym class, if you were to run it backwards, you would still run a mile. It would just be that you're backwards. So that negative doesn't apply to distances. So often we will throw that negative version out. And since most of the problems you've been working with have been with distance and length, you haven't had to deal with that negative version of the square root, okay? Now, I'm going to show you one more thing that's really important to note. What if I said 3 to the third power? Up to this point, you would say 27, correct? What if I ask what's negative 3 to the third power? And at this point, I set that up in a way that you maybe said positive 27. But again, let's think about it. Negative 3 times negative 3 times negative 3. A negative 3 times negative 3 we already established is a positive 9. So I have a positive 9 times a negative 3. Positive times a negative is negative. And 9 times 3 is 27. So a negative 3 to the third power is a negative 27. So notice that when you're dealing with cubes, it's possible to get a negative answer. Okay, and that means that if I were to ask for the cube root of 27, you would say 3. If I were to ask the cube root of a negative 27, you would say negative 3. Alright, and not that you're using calculators yet, but I do want to just show you one more thing. If I asked you what is the square root of a negative 9, if you were to ever type that into your calculator, you're going to get an error. And the reason is there's no way to get to a negative 9 by squaring a number, right? Because a negative times a negative is always going to be positive. So if you were to type this into your calculator, depending on what one you have, you might see domain error, or you might see non-real answer. Okay. Um, and when you move into more Algebra 2, you're going to start learning how to work with those non-real answers. But for now, it just usually means that you did something incorrectly. Okay? All right, let's move on to our first example. Darius is restoring a square tabletop. He wants to finish the outside edges with a piece of decorative molding. Okay, so molding is just something that goes around the edge, and it can be around the edge of a room, it can be around the edge of a table. It just kind of gives it a finished look. Okay, what is the total length of molding Darius will need? So we need to figure out what is that side length, so then we can multiply it by 4 to figure out the total length of the molding. Now that we are practicing writing some equations, you will see that I'm using this formula: area equals the side squared when you're dealing with a square. So instead of writing the capital A, I replace it with 25 equals the side squared. Now I want you to practice writing out these steps, okay? Because it's going to build a foundation for future things that we do. So you can see that my next step would be, I'm going to do the square root, okay? And you can see I added a square root to the left side. And when we're working with equations, what you do to one side, you always have to do to the other. It's almost like if you think of like a balance, it's going to balance your equation. All right, so then the square root of 25 then we would say would be positive or negative 5 equals the side length, but can't have a negative side, right? So I know that my side length has to be 5 feet. And you might be wondering, why are you making us write that positive negative if we're just going to take the positive version? And honestly, it's just practice, so that way you develop a habit for later in mathematics. So that way it's your habit, and you're not going to lose points later and have to relearn. Okay? So I'm not trying to be mean. I'm trying to help you build a good foundation for future math. Okay? That's going to come in handy a lot in Algebra 1 and anything beyond that. Okay, so we know the side length is 5 feet. So if I know that this is 5 feet, all of these sides are 5 feet because it is a square. So 5 times 4 tells me that I would need 20 feet of molding, decorative molding. All right, I have answered the first question. Now I want you to determine what is the side length S of the square shown. You can see these little boxes here. You're going to fill in these boxes. I want you to actually write out all of these steps, but you put what you think belongs in those boxes, and then below I want you to list your final answer. Good luck. All right, for this problem, hopefully your work looks something like what is shown on the screen and your final answer was 10 meters. If not, please be sure to reach out for some help. I'm happy to help you. Let's move on to example 2. Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions for the screen? So you can see that the volume of that terrarium is 343 cubic feet. So I want to determine, so in this case, I have volume equals 343 cubic feet, right? So what I need to do is that is my total volume, right? So volume would equal the side length cubed. So I'm going to put 343 equals my side length cubed. And then just like the last step, I'm going to do the cube root of 343 equals the cube root of the side length cubed. And then, since this is a cube, I know that my answer is going to match whatever the sign is. So it's a positive 343, so I know my answer is going to be the positive version. And the cube root of 343, if you look back at your chart, is going to be 7. Okay, so I know that my side length is 7 feet. And I want to know, what are the dimensions for the screen? Well, it's a square screen, so 7 feet by 7 feet. So I would write 7 feet by 7 feet. And there are a couple of different ways to write this. Some of you like to write it using the X, and some of you like to write it using the word by. And then as far as feet goes, I'm actually going to introduce you to what if you were working in like really any profession that involves like the labels feet or inches, you'll discover that they use a little tick mark instead. A single tick mark represents foot. If you were to have 2 tick marks, that would actually mean 7 inches. Okay, so if you would like to switch to the tick marks, I'm okay with that. However, make sure that I can read your writing and it's very clear that that is what you're doing. You are labeling with that tick mark. All right, your turn. Go ahead, solve the x cubed equals 64. Good luck. All right, hopefully for this problem, you looked back at your cube root chart and you saw that 4 cubed is 64. So you determined x equals 4. I do still want you to practice writing out that work, okay? So if you just wrote the number 4, you got the right answer, but I would not give you full credit. You need to practice writing out that work. All right. Now we're going to kind of combine everything that we have practiced up to this point. So here we have x squared equals 50. Okay. Again, I'm going to undo that square by doing the square root of x and then the square root of 50. And if I were to look at that, that's not a perfect number. So what I would actually do is I would leave it in that square root. In future math classes, you'll learn how to simplify that a bit more. I'm not talking like decimals. I'm talking about simplifying. It's called simplifying radicals. It's where you simplify that square root, okay? But for now, you're going to leave it in this form right here. Okay, now let's look at this other one right over here. I have x to the third equals 37. So again, I would take the cube root of x cubed equals the cube root of 37, and I would be left with x equals the cube root of 37. And since this is a positive number here, I'm not going to write a plus or minus. That's only for squares. Okay, and you might be wondering, well, if it was a negative 37, would I write x equals negative cube root of negative 37? And the answer is no, because if you were to write it with the negative inside that square root right there, you're automatically going to get a negative number. If you were to put a negative outside of here, what it would end up doing is technically making it a positive, because it would be a negative times a negative. Okay, so writing out the plus or minus, that only applies to squares, and then you don't really need to worry about with cubes. All right, now let's look at the last thing for today. This is what I was talking about when I said, hey, there's a kind of a challenge problem on this assignment. Let's see if you can do it. Well, the challenge problem, I believe you can do it. It's just going to take you a minute to learn a new skill, and that new skill is something called percent of change. There's a formula for this. Okay, so for this formula, you start out by taking your new number. You can see I have two numbers listed here. I have new number and an original number. So what you do is you say new minus original. Okay, and I'm going to write that out in a different color down here. So new minus original, so 81 minus 54. Okay, and if I were to actually simplify that, 81 minus 54 is 27. Okay, then what you do is you make it a fraction over the original number. Okay, so if I were to take the pen again, this would be over 54 because that's my original number. So again, I would have 27 over 54, and I'm just going to take a moment to simplify that. 27 over 54, that's the same as saying 1 over 2, right? Because 27 is half of 54. Alright, the next thing you do is you take that number and you multiply by 100. Okay, so you take the number and you multiply by 100. So 1/2 times 100, that would just be 50. So I would say that this is a 50% change. Alright, so that's how you solve for percent of change. And that's a very quick overview of it. If you need some help with that, please be sure to reach out for some help. If you need help with anything in this video, reach out for help, okay? I am more than happy to help you, and I hope you have a great day.